Welcome back. We're going to take a look at another topic in our data analysis unit, specifically calculating what are called measures of center and measures of variability. We are also going to talk about when we use these calculations and what types of questions we can answer with them. So let's get started. Unfortunately, when I first designed this lesson, I had intended for us to capture our data together in the classroom. I had originally intended to run a timer for 1 minute and have each student in the class measure their heart rate. Then we were going to fill our data table and use our own heart rate data for all of the subsequent calculations. Since we can't come together to collect that data, I ran 2.5 miles for us. I ran uphill wearing my Apple Watch to collect some heart rate data. I used a training approach called high-intensity interval training. In this style of training, you do real intense exercise for a brief interval, say 2 minutes, and then follow that immediately with a less intense exercise for the next 2 minutes. Then you repeat the cycle. In this example, I ran for 2 minutes, followed by 2 minutes of walking, then 2 minutes of running and 2 minutes of walking, and I continued these 4-minute intervals for a total of 34 minutes or 2.5 miles. The result is that the heart rate data varies. From the Apple Watch output, you can see at the beginning of my workout, my heart rate was 102, and then it maxed out at 181. For this activity, I'm going to fill in the heart rate data table for every 30 seconds until I reach 35 data points to fill the table. Now that I have my data table filled in, I went ahead and calculated the sum of all the data, which was 5,563. We're going to start by calculating the measures of center, which we learned about in 6th grade. Let's recap how to do these calculations. For the mean, you're going to take the sum of all of the data in the set, which is 5,563, and divide it by the number of data points in the set, which is 35. The mean of this data set is 158. and 9/10. For the median, you will need to arrange your data in order from least to greatest. Then find the middle value of the dataset. The median of this dataset is 161. For the mode, once your data is organized, you'll look for the most frequently occurring value in the dataset. A dataset can have more than one mode or no mode at all. This dataset has 2 modes, 170 and 155. In the previous video, we talked about quartiles, which split our dataset into 4 segments, each of which contains 25% of the data from the set. Quartile 1 is the median of the lower half of the data, while quartile 3 is the median of the upper half of our data. One of the measures of variation we'll talk about today is called the interquartile range. This is the difference between quartiles 1 and 3. It's also the width of the rectangle in our box plot. The interquartile range is often called the IQR for shorthand. It tells you that 50% of your data lie within this range. It is also possible to calculate the overall range for your dataset, which would be the difference between the least and the greatest values in the set. While these calculations are not difficult, they can be a little bit time-consuming. Luckily, we can automate most of these calculations using Desmos. The worksheet I'm showing is linked in the description of this video, and it's also present on the QR code of your paper. Notice first that I've created a list of heart rate data from my paper using the capital L followed by the equal sign in the square bracket. From there, I typed all of my data points and separated each of them using a comma. In the Measures of Center folder, I've shown that you can type the word mean or median followed by the parentheses L. You can also ask Desmos to find the sum of your data by typing in total. In the Measures of Variation folder, I've shown that you can find the minimum and maximum values by typing min followed by parentheses L or max parentheses L. The range can be found by subtracting the maximum and minimum values. As shown in a previous video, you can find quartiles 1 and 3 by typing quartile followed by parentheses L, comma, 1 or 3 depending on which quartile you want to find. To find the interquartile range, just subtract Q3 and Q1. The interquartile range is referred to as a measure of variability because it indicates how close or how far our data points are from one another. Another measure of variability is called the mean absolute deviation. The notes on your page indicate the process for calculating this statistic manually or by using the TI calculator. To summarize, we're going to find the mean of the dataset. Then we're going to find the difference between every individual data point and the mean. Next, we ensure all of those differences are positive by using the absolute value. Last, we average all of those differences. This is our mean absolute deviation. Once again, Desmos comes to the rescue by automating this calculation. In the final line of the Measures of Variation folder, you'll see the command MAD followed by parentheses L. This allows us to calculate the mean absolute deviation directly. In contrast to the measures of center, which describe a typical or a middle value in our data set, measures of variability tell us how much our data fluctuates. If your IQR, or MAD, is a smaller value, this usually indicates that your data is less variable and data points are relatively similar to one another. On the other hand, if your IQR or MAD are larger values, this generally indicates that your data is highly variable and tends to show a wider range. This wraps up our discussion of measures of center and measures of variability. We still have lots of great data topics to look at over the next several days. See you next time.